Alright, so in this video, we will learn how to predict or explain the relative melting temperatures of ionic compounds. Okay, so this video is going to be focused on melting temperatures. Melting temperatures of ionic compounds. So when it comes to the melting temperature of ionic compounds, what we need to know is all about the strength of interactions between the cations and the anions in the ionic compound. Okay, so we know that ionic compounds are made of cations and the anions, and then stronger the attractive interaction between the cation and the anion, the higher the melting temperature. Okay, so let's write this down once so that we know what we're dealing with. So the stronger the ionic force between the cations and the anions. Okay, the higher the melting temperature. Okay, now what we want to focus here is the ionic force then. Okay, so if we can determine the relative ionic force strength, okay, then we can have an idea about the relative melting temperatures of ionic compounds. Okay, so in an ionic compound, what we have is charges, plus and negative charges. All right, and then this ionic force, let me call it F. Okay, I'm gonna call this F. Okay, the ionic force is directly proportional to the charge product. What I mean by the charge product is the charge of the cation, Q sub plus, times charge of the anion. Okay, we only care about the absolute value of this, but anyway, the charge product, and inversely proportional to the distance between the ions squared. Okay, so I'm gonna go over what I exactly mean here. Okay, so let's say that we have the plus ion. Okay, and then we have the negative ion. Okay, so stronger the greater the charge product of the positive ion and the negative ion, stronger the ionic force, right? And this is what this relationship tells us. This is coming from the Coulomb's law, by the way. We may have seen this. F is equal to 1 over 4 pi epsilon. And then we have Q plus, Q minus over R squared. So this is coming from that. Okay. So only thing we care about is the charge product is directly proportional to the ionic force. And then the distance between the ions is inversely proportional to the ionic force. That's what matters to us. Now, we know what is meant by the charges. We know how to determine the charges of a given compound. And just to clarify what is meant by the distance between the ions, so R. So the distance from the center of the cation to the center of the anion is defined as R. Okay, so here the R is the distance between the ions. The distance between the cation and the anion, and then Q plus is the the charge of the cation, and then Q sub minus is the charge of the anion. Right, just for clarification. Okay, now what we're going to do now is we're going to try to apply this so that we understand what is meant by this. Okay, so let's try to do it on the same page so that we have everything in front of us really quickly. Let's think about calcium. Let's say magnesium. Okay, let's think about sodium oxide versus magnesium oxide. Okay, sodium oxide is Na2O, and then magnesium oxide is MgO. Now, the first thing we're going to do is when we are given, so the question is, which one do you predict to have a higher melting temperature? Okay, so the first thing we're going to do when we are given a question like this is we need to decide the charges of the ions. Okay, so let's write the charges. Okay, so that means Q plus and Q minus. Okay, so sodium is going to be always +1, oxygen is going to be -2, and then magnesium is going to be +2, and oxygen is going to be -2. Okay, so if you calculate the charge product, okay, so the charge product for, let me write this down again, charge product for sodium oxide is, I'm going to take the absolute value here, 1 times 2, 2, and the charge product for magnesium oxide is +2 times -2 is -4. The absolute value should be 4. Okay, so we have a greater charge product in magnesium oxide compared to sodium oxide. Therefore, we can expect the ionic force to be stronger in magnesium oxide. Okay, since magnesium oxide has stronger ionic force, then you can expect magnesium oxide to have a higher melting temperature than sodium oxide. And this is how we use the Coulomb's law, or this relationship over here, to determine the relative melting temperatures of ionic compounds. Okay, so let's do another one. This time let's do magnesium oxide versus calcium oxide. Okay, so let's say that we have magnesium oxide, and then we have calcium oxide. Okay, so the charges wise, they all have the same charges, right? So magnesium is +2, oxygen is -2, calcium is +2, oxygen is -2. So the charge product in both cases will be 4. So the charge product doesn't cut it. Okay, so when the charge product doesn't help us, what we do is we're going to consider the distance between the ions. Okay, so if you think about these ions, so if the magnesium ion is this much, okay, and oxygen is this much, okay, that ion of calcium oxide, oxygen will be of the same size. So this is the oxygen, O2 minus ion. But when it comes to calcium compared to magnesium, you know that calcium is below magnesium. So when you go down a group, okay, just to remind us, so we have magnesium, calcium, strontium in the same group, right? So when you go down the group, you are adding shells. Each shell is bigger than the previous shell. Therefore, calcium is going to be a much larger ion than magnesium 2+. Okay, so if you think about the distance between the ions now, so the distance between the cation and the anion in magnesium oxide is about this much. Okay, but when it comes to calcium oxide, the distance between the ions is going to be much larger. Okay, so this is going to be calcium oxide, and this is going to be magnesium oxide. Since the distance between the ions are larger, okay, you're going to have weaker ionic interactions. Okay, so ions can interact strongly when they're closer to each other rather than when they're far apart from each other. In magnesium oxide, the ions are closer to each other, and as it is compared to calcium oxide, and therefore you're going to have a stronger ionic force in magnesium oxide. Therefore, it's going to have a higher melting temperature. Magnesium oxide will have a higher melting temperature than calcium oxide. Okay, so this is how we use this relationship again to predict the relative melting temperatures of ionic compounds. I hope this helped. I'll see you guys later in class. Bye, everybody.